So what if the most powerful, the most intelligent things in our world aren't actually designed? What if they're grown? It's a pretty wild idea, right? But today we're diving into exactly that, this radical concept that true control, real power, comes from letting go. And this all comes from Kevin Kelly's groundbreaking book, Out of Control.
All right, to really wrap our heads around this whole thing, let's start with a little puzzle. And trust me, it seems simple, but what's hiding underneath, well, it reveals this incredible truth about how the world actually works.
So think about that. Where is that extra memory? I mean, it's not in any one bee, right? Some of them don't even live that long. The answer, and this is the key, is that the memory lives in the connections, in the patterns of how all those bees interact with each other. It shows you that the whole hive isn't just more than its parts. It's something totally, fundamentally different. And this amazing phenomenon? Well, it has a name. It's called emergence. You can think of it as the ghost in the machine, or maybe the unexpected genius that just appears out of a crowd. It's that bit of magic that happens when a bunch of simple, dumb parts start talking to each other in just the right way.
Okay, here's a great way to picture it. Think about a whirlpool in a drain. You could study a single H2O molecule for 1,000 years. You could know everything about it, and it would never tell you anything about the vortex. Not a thing. You only see that powerful, swirling pattern when you see the whole system moving together. And that's the thing about these complex systems. The only way to know what they're going to do is to just let them run.
Okay, so if this intelligence isn't coming from some central command post, there's no queen bee up there barking orders, then where in the world does it come from?
It comes from what we call the logic of the swarm. So instead of thinking about a pyramid, with a boss at the very top, I want you to picture a web. There's no center. There's no single point that if you take it out, the whole thing falls apart. The control is everywhere and nowhere, all at the same time. And this quote just hits the nail on the head. It shows you the network's secret weapon, its paradoxical strength. All that messiness, that redundancy, that's not a bug, it's a feature. Think about it. A strict hierarchy, it's brittle. You cut off the head, the whole thing dies. But a network? It can handle all kinds of little failures and glitches because there are always a dozen other ways to get the job done.
Yeah, and unlike that rigid pyramid, a network can grow and adapt and learn in ways that are just impossible for a system with a central boss. You can add more birds to a flock. It doesn't get full. You can plug millions of new computers into the internet, and the whole thing just keeps on humming. And get this, it's the only structure that's capable of learning all by itself, with no one there to teach it.
So, if this is how nature builds intelligence from the bottom up, the big question is, can we do it too? Can we copy that playbook? And this is where the story of robotics gets really, really interesting. You see, for years and years, the old approach was a total dead end. Researchers poured fortunes into trying to build one single, super complex, genius computer brain that would tell the robot's arms and legs what to do. And the result? Clunky, expensive machines that could barely make it across a flat room without falling on their face. But then, this robotics pioneer named Rodney Brooks came along and just flipped the entire problem on its head. He said, forget building one smart thing, let's build a bunch of dumb things. And he created these little insect-like robots, like one called Genghis, this little six-legged guy. And its movement was so shockingly lifelike. And it all just emerged from these simple parts working together. Absolutely no central brain needed.
And this gets us to Brooks's secret recipe, which is so important. The big idea is that complexity has to be grown. You can't just design it all at once. You start with something super simple that works perfectly, like move forward. Then you add a new layer on top of that, like, okay, and if you bump into something, turn. The key is you never mess with the simple stuff that already works. You just keep adding new, simple layers, one on top of the other, forever.
And this idea fits perfectly with what another pioneer, Marvin Minsky, called the society of mind. His theory was that what we think of as intelligence isn't one big, shiny, brilliant thing. No. It's more like a messy, chaotic committee of a bunch of simple, mindless agents all shouting at each other. As Minsky famously put it, you can only get smart things from stupid things. It's a wild thought, isn't it? You don't design a genius, you assemble it from a mob of morons.
Okay, so this whole idea of growing complexity, it's not just for building robots, not at all. It's actually changing how we think about the entire natural world, and it's starting to blur the lines between what's born and what's made.
To see what I mean, just look at the story of David Wingate. This guy dedicated his entire life to saving one single species of bird, the cahao, on this one tiny island. You'd think that's a pretty focused, noble goal, right? Well, it turned out to be way more complicated than that. Because what he found out was just profound. He realized you can't save one little piece in isolation. It doesn't work. To save the bird, he first had to rebuild its entire world. He had to plant the forests, which brought back other animals, which then started to balance out the whole ecosystem. And then, finally, the bird could thrive. He couldn't just save a part. He had to grow the whole living system.
And believe it or not, this is happening on a massive planetary scale now. We are creating what are called synthetic ecologies, systems that weave together the natural and the technological. I mean, think about the Great Lakes. That's a huge natural ecosystem that's also heavily managed by us. It's this new kind of hybrid world.
So the goal is really shifting, away from what you might call governance by engineering, where we try to control every last detail, and more towards governance by biology. The idea is you set up the right starting conditions, you plant the right seeds, and then you let the system's own internal logic take over. You have to trust it to manage itself.
And all of this, it brings us to the final point. And it's probably the most challenging, but also the most important idea in this whole explainer. It's what we could call the great trade-off. If we want to get all the amazing benefits of these living, evolving systems, their creativity, their resilience, their ability to learn on their own, we have to give something up. We have a choice. On one hand, you can have full control, total predictability, but your system will be brittle, it'll break easily. Or you can let go of some of that control and get something that's a little messy, a little unpredictable, but is adaptable, resilient, and almost impossible to kill.
What this means is we have to be willing to give up that deep-seated desire for total top-down control. We just have to. Because any other kind of organization, anything that isn't a network, automatically puts limits on what's possible. It decides the ending before the story even starts. A network is the only thing that's truly open to surprise.
And that leaves us with this huge critical question. How do you give something you create a purpose, a destiny, without taking away its freedom? The answer seems to be that we have to learn to become partners with our creations, not their masters. We can provide the seed, we can provide the soil, but we can't hand it a blueprint for the tree. We can set a direction, but not a final destination. Because it looks like the future is going to be less designed and a lot more grown. In a world that's only getting more complex, the most powerful things aren't going to be the ones we command, but the ones we cultivate. And maybe the biggest challenge of all for us is just learning to get out of the way and let them grow.